This video lesson corresponds to sections 7.6 and 7.7 of your text, which details the ways to classify and categorize chemical reactions. Now, we've already done some of this when we talked about double exchange reactions that produce precipitates. We talked about neutralization reactions between an acid and a base, which is another kind of double exchange reaction producing water. We talked about redox reactions, and in particular we talked about combustion, a certain type of redox reaction. And on the board up here you see another type or category of chemical reaction called single exchange reactions. And a single exchange reaction is when one element replaces another in a compound. So algebraically it's shown here when the pure element A replaces B in the compound BC, you end up with another pure element B and a new compound AC. So a sort of tip-off that you've got a single exchange reaction is that you have a pure element as a reactant and as a product. They are different pure elements, however. This is also another type of redox reaction. If you think about it, remember the oxidation state of pure elements is always 0. So let's take A as an example. A in this case is a pure element as a reactant, but as a product it is in the compound AC, and it looks like it's a cation there because it's listed first. So this takes on a positive oxidation state and is therefore oxidized. B must be reduced. B is positive over here, but oxidation state of a pure element is 0. So B is reduced. So again, single exchange, another type of redox reaction. Here's one we've seen before. When you react a metal with hydrochloric acid, you produce hydrogen gas and a salt, zinc chloride. We did this when we collected hydrogen and exploded the balloon, pretending that it was the Hindenburg in the process. This is not balanced, by the way. We have 2 hydrogens, so I need to double my HCl, and chlorines are taken care of. So anyway, this is a single exchange because zinc, shown here, replaces the hydrogen and forms zinc chloride, and another pure element is formed, hydrogen. So you have a pure element as both a reactant and a product. There's another famous single exchange reaction called the thermite reaction. The thermite reaction is simply powdered aluminum, shown on the left, reacted with rust, iron 3 oxide. And that needs a high temperature to initiate the reaction, but it's extremely exothermic. It was used as bunker buster bombs in World War I and World War II because the heat generated is intense enough to melt metal armaments on the outside of tanks or bunkers. And I will do a brief demonstration of this as well. Obviously also not balanced. So I need 2 irons, so I will double this right here. Looks like I'm going to need, I've got the odd even. Oh no, I don't. With oxygens I'm fine. So I double my irons, and if I double my aluminums over here, it looks like I'm okay. Another type of category of reactions is a synthesis reaction. And a synthesis reaction is when a new compound is formed from 2 or more reactants. So algebraically it's shown here, A plus B yields C, C indicating a new product is formed. I will show you a video of this tomorrow, which is pure element sodium and elemental chlorine gas, diatomic of course, will react spontaneously to form salt, NaCl. And of course this looks like it needs a little balancing too. I need to double my chlorines and then double my sodiums, and I'm okay. This is another type of redox reaction because, again, pure elements have the oxidation state of 0, chlorine as well, but in a compound, sodium is Na+, it's oxidized, chlorine is Cl-, it is reduced. Now the final type of reaction category that we should talk about is a decomposition reaction. And a decomposition reaction sounds like what it is. A compound is decomposed into simpler materials. So you have algebraically A, some compound breaks down into B and C, 2 new and different materials. the best example of this is peroxide. Hydrogen peroxide that you buy at CVS will have an expiration date on the bottle. Look for that next time you're at the drugstore. And the reason it has an expiration date is because it spontaneously decomposes into water and oxygen gas. So it has a shelf life, and you cannot slow that down. Well, you can. You can change temperature or keep it out of sunlight, but it will happen, and there is an expiration date for that reason. Another famous decomposition reaction is this one right here. Now that looks complicated, but we can name these materials. On the left is ammonium nitrate. So look at the polyatomic ions, ammonium nitrate, solid. And when that is decomposed, it has to happen at high temperature, but it will decompose. You produce a whole bunch of gases. Notice 2 molecules of nitrogen gas and oxygen and 4 waters. And this temperature, again, happens at a very high temperature. So although it says liquid for the phase of matter shown there, although it says liquid, it's at a high enough temperature that it is actually a gas of water vapor. So you start with 2 molecules of a solid, and you produce 7 molecules of vapor, of gas. And so this expands explosively. And if you are familiar with one of the great meaning large, incidences of domestic terrorism in the United States was the Oklahoma City bombing in April 1995. The Alfred P. Murrah building in Oklahoma City was that bombing killed almost 170 people. It damaged 300 plus buildings, caused $650 million worth of damage. What was the bomb made out of? Well, fertilizer. And fertilizer is ammonium nitrate, shown here on the left. So this material, when ignited with an accelerant, and they use diesel fuel to do that, goes through this decomposition reaction and expands explosively, creating a shock wave that is powerful enough to destroy buildings and take lives. And so this material, which is now actually a controlled substance, ammonium nitrate, is carefully watched over by the federal government to see who's buying quantities of it. Normally farmers, because it's used as a fertilizer. And so we finish up here just by looking at a quick summary of the possible ways to categorize chemical reactions. You've got double exchange reactions, which will produce a precipitate. That's shown here. Precipitate's obvious when it comes to visually identifying it. You've got another kind of double exchange reaction, which produces from an acid-base neutralization, which of course produces water. And then you've got redox here in the middle. And there's lots of subcategories of redox. Combustion reactions we talked about, and then the 3 we just talked about today. Single exchange reactions right here. Synthesis reactions, where the reactants are elements or other compounds that end up as a product of a new compound, and then decomposition reaction. And that's all I have for this quick video lesson. Thanks very much, and get back to work.